You know, if you're planning to build a backyard retreat, especially in a place with punishing weather, it is just so tempting to only think about the surface level.
Oh, absolutely. The fun stuff.
Right, the fun stuff, you picture the lounge chairs, maybe a nice wooden deck, some string lights.
Hmm.
But stepping into the backyard in a place like coastal Florida, well, it is really like stepping into a heavyweight boxing match.
That is a very accurate way to put it, yeah.
Yeah, because you put down a flimsy wooden deck or maybe some loose pavers, and they are going to get knocked out early in the first round. I mean, they get battered by the tropical sun, the humidity splinters the wood, and the pavers just shift and sink into the sand.
And then hurricane season rolls around.
Exactly. Hurricane season delivers the final crushing blow. So to win that fight, you really need the undisputed heavyweight champion of outdoor living, which is a custom-engineered concrete slab.
Yeah, there is just no substitute for it in that kind of environment.
Today, we are tearing up the blueprints of standard backyard patios. We are looking closely at operations down in coastal Florida specifically. We're pulling from the engineering standards of Palmetto Concrete. We really want to uncover the hidden physics, the chemistry, and the sheer structural warfare required to build a permanent outdoor space.
It is a massive undertaking.
It really is.
Right.
Okay, let's unpack this because it turns out pouring a patio that actually survives is a lot more complicated than just mixing some gray powder and water.
Oh, it's a completely different mindset. I mean, the most important paradigm shift here is moving away from the idea that a patio is just some cosmetic landscaping project.
Right, it's not just planting bushes.
Exactly. When you are dealing with extreme coastal climates, or really any environment that experiences intense weather swings, treating an outdoor space as a strict structural necessity is the only way to avoid catastrophic failure.
You're not just decorating the yard.
No, not at all. You are engineering a permanent, load-bearing response to the local environment.
Which means we can't even talk about surviving a hurricane above ground without first dealing with the literal dirt beneath our feet. I mean, the source material makes it incredibly clear that the soil in the Palmetto region is notoriously sandy.
Yeah, and sandy soil is a massive structural liability. I mean, if a contractor ignores the subgrade, and by that I mean the actual earth beneath the planned patio, well, the entire project is doomed before the first cement truck ever rolls up to the curb.
Because you can't build a heavy structure on sand.
You simply cannot build a heavy, rigid structure on shifting sand. It just won't work.
So they don't just, clear away the grass and start pouring. They have to physically remove the problem first.
They do. It all starts with stripping away all the organic topsoil.
Why specifically organic?
Well, this is crucial because organic material, things like roots, grass, decaying, leaves, it decomposes over time. And as it rots away underground, it creates these microscopic or sometimes actually rather large voids in the earth.
Oh, wow. I didn't even think about that.
Yeah, so if your concrete is sitting on top of that, it suddenly has no support underneath. It's just floating over an air pocket.
Right, which sounds like a disaster.
It is. So once that problematic topsoil is completely gone, they bring in a specific structural fill dirt.
And even then, I mean, just dumping new dirt into a hole isn't the fix, right? They have to compact that fill until it's practically harder than highway asphalt.
Oh, absolutely. That intense compaction is non-negotiable. Industry engineers, like those at the American Concrete Institute, they consistently point out that proper subgrade preparation is the single most critical factor in preventing flexural failure.
Flexural failure, which happens when the ground beneath the slab settles unevenly.
Exactly.
So if there's a void underneath, the concrete ends up carrying its own weight across empty space, causing it to bend, and concrete absolutely hates bending.
Right, when concrete flexes under a load, it just snaps. I mean, it has incredible compressive strength, meaning you can park heavy vehicles on it all day long.
But it doesn't like to stretch.
Exactly. It has terrible tensile strength. It really doesn't like to be pulled or stretched in any way.
Which brings us to the hidden skeleton of the whole operation. The sources mention the use of heavy-duty vapor barriers and a very tight grid of steel rebar laid down before the pour. Because, as it turns out, concrete and steel have a very symbiotic relationship.
They really do. They need each other.
Yeah. I like to think of it like the human body. The concrete acts as the bones. It handles the heavy, crushing, compressive loads. But that steel rebar acts as the tendons and ligaments. It holds the whole skeleton together, providing that missing tensile strength when the ground inevitably shifts.
What's fascinating here is how that hidden framework dictates the entire lifespan of the project.
Because the ground is always going to move a little bit.
Oh, it will. When the ground does shift, and in a coastal environment with changing water tables and torrential rains, it absolutely will shift. That steel rebar is what prevents a minor stress point from turning into a massive fissure.
So it's actively holding the slab together.
Exactly. Without those steel tendons holding the slab in tension, a tiny crack could easily split the patio right down the middle after a major Gulf storm. The steel is just down there doing the invisible, thankless work of keeping the whole system tight.
Okay, so we have our compacted subgrade, our vapor barrier, our steel pendants. The skeleton is ready. Now we need the actual flesh of the patio. And the standard bags of mix you'd grab from the local hardware store, well, they're definitely not going into this frame.
No way. A residential bag mix is, fine for setting a mailbox post, but for a permanent home addition, you need a custom-batched, highly engineered mix.
Right.
The standard specification they use for these exterior patios is a 4,000 psi concrete mix. This provides vastly superior density and resistance to surface wear compared to your standard 2,500 or 3,000 psi residential pours.
Wait, 4,000 psi? That sounds like we're building a structural ramp for a commercial parking garage. Aren't we slightly over-engineering a place meant for drinking iced tea and reading a book?
I know, it definitely sounds like overkill if you are only thinking about the static weight of your patio furniture. But the real enemy here isn't the weight of a grill or a lounge chair.
What is it then?
It is the constant thermal expansion and contraction, the microscopic impacts of rain, and just the general weathering over decades. A 4,000 psi concrete is chemically denser.
And denser means better.
Yeah, because it's denser, it's fundamentally less porous. It leaves fewer microscopic capillary tubes for water to infiltrate, which makes it far more resistant to the elements. But, the high compressive strength is actually only part of the chemistry.
Here's where it gets really interesting, because this modern mix isn't just rock, water, and cement anymore.
No, it's a highly engineered composite. They integrate synthetic fiber mesh directly into the ready-mix trucks before the mud is even poured.
Synthetic fibers, like microscopic plastic threads mixed straight into the mud.
Exactly.
I mean, how does a piece of plastic stop a heavy concrete slab from failing?
Well, imagine millions of microscopic fibers weaving a three-dimensional web throughout the entire batch of wet concrete.
Okay, I'm picturing it.
As the concrete cures and dries, it naturally loses moisture and it shrinks. That shrinkage naturally creates microscopic stress fractures internally.
So it's breaking on the inside while it dries.
Sort of, yes. But these synthetic fibers act as physical bridges across those microscopic gaps. They cite organizations like the National Ready Mixed Concrete Association on this. The fibers physically intercept and arrest those microcracks before they ever reach the surface.
Wow.
By locking the mixture together at a microscopic level, it drastically improves the long-term durability of the flatwork. It is literally stopping structural failures before they are even visible to the naked eye.
It's basically micro-armor mixed right into the mud. That is incredible. But, the fibers in the steel are really only protecting the slab from cracking under pressure. None of that internal armor matters much to a homeowner if the surface looks like a dull, gray municipal sidewalk. So we've built this indestructible, heavy-duty foundation. How do we make it actually look good in a high-end backyard?
This is where we see a real intersection of structural engineering and high-end architectural design.
Right.
The modern concrete industry has completely smashed the boring gray stereotype. Through stamped and stained concrete, they can achieve high-end aesthetics that flawlessly mimic natural materials, but without the inherent vulnerabilities of those materials.
Yeah, the source gives some great examples of this. If you want the rustic look of reclaimed wood, they can actually stamp that texture right into the concrete.
It's amazing.
You get the exact visual, but you have zero termite risk, and it won't warp in the humidity.
Yeah.
Or, if you want the look of natural flagstone, you can have it. And you don't have to pay the astronomical price tag of mining and shipping heavy real stone across the country.
And it goes far beyond just pressing a rubber stamp into wet mud. In the Manatee County region, for example, they utilize highly advanced decorative finishing techniques to really sell the illusion.
What kind of techniques?
Well, first, they use interval colors. That means the base color is mixed directly into the concrete batch at the plant, so the color runs completely through the slab.
Oh, so if it ever chips, it's still that same color underneath.
Exactly. It's not just painted on top. But then, to create the real texture, they apply topical antiquing release agents on the surface.
Let's drill into that for a second, because if you're pressing heavy polyurethane stamps into wet concrete, wouldn't the stamp just act like a suction cup and pull the mud right back up when you lift it?
You would think so, yeah.
So how do they get those dark, realistic crevices without just completely ruining the surface?
That is exactly what the antiquing release agent prevents. Think of it like a baker dusting flour onto a countertop before rolling out dough.
Okay, that makes sense.
The release agent is a dry powder that stops the stamp from sticking to the wet concrete, but it also serves a secondary aesthetic purpose. It is heavily pigmented, usually in a much darker color than the integral base.
Oh, I see where this is going.
Yeah, when the stamp is pressed down, the physical pressure forces that dark powder into the deepest recesses and joints of the texture.
So when they wash the excess off later, that dark pigment stays in the low points, creating these sort of artificial shadows.
Exactly. It breaks up the uniformity, creating a deep, multidimensional finish that looks organic and authentic. It gives the stone or wood grain that expensive, weathered look.
That's brilliant.
And there is a massive practical benefit here, too. Because it is a single, solid slab simulating the look of individual stones or planks, there are no actual joints.
Which means no dirt settling between the pavers and no weeds ever sprouting through your patio.
None.
That alone is a massive selling point. I mean, it makes total sense why the concrete network and other industry data consistently show stamped concrete as one of the highest return on investment hardscaping choices a homeowner can make.
If we connect this to the bigger picture, homeowners aren't just looking for a flat, decorative surface anymore.
No, they want actual outdoor rooms.
Exactly. Whether they are on Sneed Island or over in historic Palmetto, they want highly functional, specific living zones built directly into their outdoor spaces. And you just can't apply a one-size-fits-all approach to those zones because different uses require different engineering underneath.
Right, let's look at what I call the pizza oven problem.
Oh, the pizza oven problem, yes.
Say you're building a gorgeous outdoor kitchen and you want a heavy brick pizza oven. You cannot just plop a massive masonry structure on top of a standard 4-inch patio slab. The sheer localized weight will punch right through it, literally snapping a 4-inch slab in half.
Yeah, the math simply doesn't work there. To solve this, the engineering has to anticipate the lifestyle use before they even pour. Contractors have to dig footing trenches around the perimeter of where that heavy structure will sit.
So they thicken the slab in specific spots.
Right. They pour an 8-inch or sometimes even a 10-inch thick haunch, which is a significantly thickened edge slab specifically engineered to support that massive masonry load.
They also have to zone for fire safety. The operations detailed pouring specialized circular stamped extensions specifically for fire pit lounges.
That's a great feature.
Yeah, this ensures that any stray popping embers land safely on fireproof concrete rather than, igniting a dry, flammable wooden deck nearby. It is safety and zoning engineered directly into the floor plan.
Exactly.
So the heavy lifting is done. The patio is poured over a heavily compacted subgrade. It is reinforced with steel tendons and synthetic micro-armor. It's beautifully stamped to look like reclaimed wood. But now it's just sitting outside, exposed to the torrential afternoon downpours and the intense Florida sun.
Right, the environment takes over.
How does it actually survive the next several decades?
Well, the final defense really comes down to water management and chemical armor. Permeability and drainage absolutely dictate the survival of any patio.
Because water is basically the enemy.
Always. If rainwater pools against the foundation of your home, or sits stagnant on the slab, you have a massive structural problem on your hands. To prevent this, every single slab must be meticulously graded. They pitch the water away from the home's foundation using a very precise slope.
The source mentions a slope of about 1/4 inch per foot, which, that sounds almost invisible.
It is practically invisible to the naked eye, which is why it requires such precision with laser levels during the forming stage. But over a standard 20-foot patio, that 1/4 inch per foot equates to a 5-inch drop.
Oh, wow. That is significant.
It is. That is more than enough to quietly and efficiently move thousands of gallons of rainwater away from the property during a sudden tropical downpour. And achieving this exact precision is one of the main reasons they have to navigate the stringent Florida building code.
Pulling the permits, scheduling the inspections, it feels like a hassle to a lot of homeowners, I'm sure.
It does, but it's vital.
But the National Association of Home Builders points out that well-designed, code-compliant outdoor spaces dramatically increase a property's appeal. It's basically documented proof that the drainage and the structural work were done correctly.
Exactly.
So what does this all mean for the listener? I mean, once the inspectors sign off, how do you actually protect this engineered stone from the sun and the rain? What does the actual maintenance look like?
It all comes down to the sealing process. Unsealed concrete, despite feeling like solid rock, actually acts like a rigid sponge.
A sponge.
Yeah. At a microscopic level, it is full of pores. It will readily absorb moisture, dirt, and, oil from your barbecue grill. To armor the slab, they have to apply a premium solvent-based acrylic sealer.
Solvent-based as opposed to water-based.
Mhm.
Because I imagine the cheap water-based sealer you get at big box stores just kind of sit on top of the surface and eventually peel off.
Yes, and that distinction is critical. Water-based sealers evaporate and leave a topical film that will literally flake off after 6 months of intense UV exposure and heavy rain.
Which defeats the whole purpose.
Right. Solvent-based acrylic sealers behave entirely differently. The solvents actually break down and carry the acrylic solids deep into the microscopic capillary tubes of the concrete.
Oh, so it goes inside the rock.
Exactly. They penetrate the pores and lock out the moisture and dirt from the inside out. Plus, that deeper penetration enhances the integral colors we talked about earlier, giving the patio that rich, multi-dimensional wet look that makes stamped concrete look so incredibly authentic.
That makes perfect sense for a new build.
Yeah.
But what if you were listening to this and you already have an old, boring, gray concrete slab in your backyard?
That's a common situation.
Are they just out of luck? Like, do they have to jackhammer the whole thing up, bring in the excavators, and start entirely from scratch?
Not necessarily, no. If your existing concrete slab is structurally sound, meaning the original contractors did a good job on the subgrade, and it isn't suffering from major flexural failure or deep active cracks, there is a process called a polymer-modified concrete overlay.
But how does it actually stick? I mean, if you pour wet concrete onto a dry, cured slab, the new mud won't bond. It'll just dry up and flake off in chunks as soon as you step on it.
Standard concrete absolutely will flake off, but this is where the polymers come in. They blend synthetic polymers into the new wet mix.
Okay.
Those polymers essentially act as a highly advanced molecular glue. When they pour a thin layer of this modified concrete directly over the old slab, it bonds at a chemical level to the old surface. It essentially gives a second life to an existing foundation without the massive cost and mess of demolition.
That is an incredible bit of chemistry. Just a total aesthetic reset,
Yeah.
bonded at the molecular level. So let's look at the journey we've taken today.
It's been quite a trip.
We started deep in the dirt, stripping organic soil and compacting structural fill to fight off flexural failure. We mixed up 4,000 psi synthetic fiber mud, poured it over steel tendons, stamped it to look like luxury stone with antiquing release agents, and locked it all in with deep penetrating solvent-based acrylic sealers.
And the ultimate result of all that hidden sequential engineering is pure longevity. When a custom concrete patio is poured correctly with the proper subgrade preparation, steel reinforcement, and grading, and if it is maintained by reapplying that high-quality acrylic sealer every 2 to 3 years, well, that engineered stone will easily last 30 to 50 years, even in the brutal Florida elements.
30 to 50 years. That is practically a lifetime for a home feature, and I think that connects to a much broader point for you, the listener.
Oh, definitely.
Even if you don't live in coastal Florida, even if you never deal with sandy soil or hurricanes, the core lesson here applies to almost any major home project. True longevity requires respecting the realities of your local environment. It requires never cutting corners on the unseen foundation, the dirt, the steel, the precise grading. It's about blending high-tech engineering with everyday aesthetics so that your outdoor space isn't just visually stunning, but actually survives the test of time.
This raises an important question, though, a highly philosophical one if you think about it.
Oh, I like where this is going.
If modern stamped concrete can flawlessly mimic the aesthetic of organic reclaimed wood or natural flagstone, and if it is heavily engineered with synthetic fibers and steel to survive out in the elements for half a century, what are future archaeologists going to think when they dig up our backyards in a few hundred years?
Oh, wow.
Will they look at these polymer-modified overlays and think we built our homes on perfectly preserved ancient wooden decks? Will they be completely fooled by the fossilized illusions we left behind?
Ah, I love that, a fossilized illusion. It really is something to think about the next time you step out onto a beautiful textured patio. Are you standing on natural wood, or are you standing on the heavyweight champion of outdoor engineering? Thank you so much for joining us on this deep dive. We'll catch you next time.